Thank you, Kim, and thank you everybody for tuning in today. Just to make sure you're on the right flight, we are going to be talking about data lakes and the cloud and the different ways that you can use and extend your Hadoop implementation. I also want to say thank you to our friends at Microsoft and Radiant for being on this with us on this journey. Just some quick introductions. My name is Bob Page. I am the Vice President of Partner Product Management here at Hortonworks, and I'll be your host. And I'd like to ask John O'Brien to introduce himself, please.
Yeah, hi, this is John O'Brien, and I'm with Radiant Advisors. We're a strategic advisory and research firm.
And Matt Winkler, if you could also introduce yourself, please.
Sure thing. My name is Matt Winkler. I'm a program manager here at Microsoft, where I spend a lot of time thinking about Hadoop in the cloud and working on our HD Insight team.
So we have just the right people here. Well, thank you, gentlemen. Before we get started and underway, I'd like to ask all of our attendees a question, and that is, where are you today on your Hadoop journey? We have been able to give you 4 different options for you to choose from. If you could fill out the poll question and hit submit. It says the time limit's 5 minutes. I think we may actually not wait that long. We could cue the Jeopardy music, I suppose, while we think about whether we are researching our options or we are currently evaluating Hadoop. Maybe deep in a trial, and I guess there's always someone who wants to know what Hadoop is. I would say if you are in production, why don't you pick deep in a trial? In the meantime, let's see, anybody know any jokes? This SQL engine walks into a bar, and he says, "Do you mind if I join your tables?" All right, nobody wants to hear that. Why don't we, Kim, if you could, let's do the big reveal and see where we are on our Hadoop journey. Drum roll, please. Well, most no answer, but it looks like relatively split between researching, currently evaluating, and deep in a trial. Fortunately, only a few folks want to know what Hadoop is. We may not cover that in the detail that you want on this call, but there are plenty of opportunities to learn more later. Well, thank you. With that, let me turn over to John for the initial part of our webinar. John, take it away.
Analyst and CEO for Radiant Advisors. Basically, our background, if you're not familiar with us, like I mentioned, a strategic advisory firm and doing research. We focus on thought leadership and really what's driving companies today, pushing the edge, if you will, and helping these companies transform into really data-driven companies of tomorrow and basically today's world. So my background, over 25 years in architecting data systems. So been around from data warehousing to BI and big data for quite a number of years in the big data industry. I've been building big data systems globally for companies, architecting those for over 15 years. So I've been very hands-on, and also the CTO of a database company for a number of years. So that's just my background and our research and our clients. What we were going to share today with everybody was really the trends and drivers when we're looking at Hadoop in the cloud or the hybrid cloud specifically. What do the network of companies that we talk to, research, work with, as well as our direct clients that we are helping adopt this technology at a few of our clients right now? What's driving them to do this in the first place? We thought that was a very important place to start. So the first thing I wanted to discuss was really leading business drivers. We know that for a lot of these, there can be a lot of hype, a lot of interest, but then again, there's got to be a real business purpose behind this. And we actually see that for most companies we're talking to that are looking for cloud and looking into Hadoop are really cost-driven. Not surprising, maybe, it's kind of the basics, but one of the number one comments we got was they are being driven to scale down operational infrastructure management costs. And when you look at this, this is kind of a general thing for companies in IT looking at all systems across the board. It's just that now Hadoop and their data and analytics is also being a part of this discussion. The interesting thing we see there is the fact that within IT, they look at standards and they look at economies of scale where we have hundreds of app servers, web servers, or infrastructure, and how do we get efficient through economies of scale? And they're now putting this lens onto the Hadoop. The clusters, how many clusters, how do we simplify that, and then how do we centralize that management? Number two here, the centralizing Hadoop data management, is really talking about where they have multiple data centers and clusters between them, and they're actually looking at network costs and latency, user experience, because now they're moving data in between them because they don't have a centralized location. So the cloud actually represents geographically a central way to bring all that data and not be moving it on internal company networks, these dedicated lines between regional data centers. Because once again, with big data, it's about trying to minimize that data movement. Part of that analysis with network costs and user experience is the fact that we want to figure out where this aggregation point, or as we like to use the term, this data lake is going to live. Is it going to be closer as we have more and more external sources of data that predominate? Then we're going to push it closer to them, or do we have a lot of in-house, on-premises types of data sources, and we're going to bring it in there? That'll dictate where between the cloud, on-premises, or the hybrid nature that we're looking at. And once again, we're looking at the data movement across the internet, your VPNs, your internal LANs, and then when you get down into the servers themselves within the clusters, we're looking at the InfiniBand connections. So, and then finally, our last one I threw in here because it was just a fun quote was, we had a quote from one of our clients saying, our sister organization just signed a great deal with Microsoft Azure, and we want to leverage those shared services. And I just thought it was appropriate for today's webinar because there is the ecosystem of strategic IT relationships that we look at. Who are our partners? Where do we already have that consolidated economy of scale with resources, with expertise, with tools, with experience, with processes? So those are kind of the four leading drivers that we've seen talking to companies that are driving them to look at their Hadoop in the cloud implementation and architecture. Now, this slide is really just saying that after the business drivers discussion, usually the technical feasibility becomes the next question. And what I did here was simply list out 8 different areas, and this was actually from the reference on the bottom there. You'll see Microsoft's Big Data Solutions, where the authors outlined these 8 areas. I thought it was pretty comprehensive. I will point out just a couple of my favorites, but it's a good reference for you. Elasticity and flexibility, that's one where they're looking at the bursting kind of nature and looking at how do we get to meet the demands of our workloads. Security is always there, but proximity, when we're talking about where that data should be aggregated, is another one. The functionality, saying we have to be careful about the distributions we're working with. Usability and manageability becomes that third category that we see kind of dominate, saying that, yes, we're going to pick this driver, this optimized architecture, but do we have the tools and the skill sets and the monitoring capabilities to actually build something that's going to be hybrid? So we see the drivers really around cost and efficiency optimization. That's good. Business value. And then we start looking at the technical side, and it breaks into categories like this for you. So what I thought we'd do next is take a look at real clear for everybody what these operating models are, and maybe it's a form of maturity as well. On-premises Hadoop clusters, you're probably most familiar with. They're balanced configurations, internal connectivity, or they could be in your private cloud architecture today. And these balanced configurations really are talking about we decide that we need maybe a 32-node cluster, a 64-node cluster. We build and we deploy that. Now, in the cloud-based clusters, what's really interesting here is that it's not as clear to most people that there's really 2 options. One of them is going to be the fact that we have IaaS, infrastructure as a service. I need a place to go where I can rent servers, stand up my cluster, and because I don't have a data center. The platform as a service model is really talking about big data as a service, which is much more on demand. I need this as a service, and when I'm done with it, I can turn it off. And then we move into the hybrid architecture that we are actually seeing evolve and being worked out and implemented at companies. 3 of them here we're going to explore a little deeper, which is affordable storage, and then this access to what some of us are calling second-class data. The second one is separation between production analytics and temporary, and then the enabling of on-premises clusters to efficiently meet demands of volatility. So with those 3, what I thought we'd do is take a look at the first one here, and once again, we would say our driver is to lower cost, and the feasibility side is through an optimized platform. In this case, we see companies driven by the fact that we have a lot of data, whether it's historical data, closed data, sometimes we call it dark data. It needs to be available, but it's on a lower SLA. Even for request or working or analysis or retrieval, it's just not the same as the operational mission-critical systems. And sometimes these are driven by regulatory requirements for companies that say you must have access to 7 years worth of history or all your history, and you must be able to respond to a subpoena within 30 days. So in order to meet those, we're looking at this separation of data. Now, some people will call it an online transparent archive. These data policies are driven by time, right? Anything older than a month, older than a year, or status, closed status, that type of stuff. But they're usually in a read-only state by this time. What's key here is what we call a 1090 and 10100 model, which means avoid data movement. And so we don't bring it into a on-premises cluster and then move it to the cloud. We're going to dual feed them into both and have kind of 10% of our data on premises and maybe 100% on the cloud. So that kind of allows our elasticity to move across both easily and avoids the data movement. So that's a real key kind of design tip we've seen there. The other big one we see is backing up. Now, Hadoop clusters are great at fault tolerance, but they are clusters. So if you were to lose a data center or a geographic location, the difference is that you don't have a recovery for that. And some companies are looking at saying, we also want to include our DR capability in the cloud because it's affordable. We know that we can switch in that situation. So that's one of the, if you will, architectural kind of patterns that we see when we have the business driver of lowering cost. The second driver, flexibility. We start to get into on-demand or temporary needs combined with the fact that we have separation of workload activities and jobs, so we get into prioritizing which jobs. And it's not really to say that one is a second class or a first class type of job. It's really prioritizing to say we want to manage where it's getting executed. There is a mindset, though, and it still comes from our production versus dev and test or discovery mindset. You'll have to ask yourself whether your discovery environments are really, if we're going to make that an aggregate area, then is that also a production environment? Do we want our workloads that run our websites, our recommendation engines, our customer care applications mixed in with our discovery workload? And a lot of IT shops we're seeing are still saying, no, I'd like to have those be a little bit on demand or separated, like a dev test mentality, versus mission critical applications where they get really into protecting that SLA. So here we have 3 different sandboxes type of environments, proof of concepts, and separating out the event, the SLA-driven ones. Discovery sandboxes are sometimes, what makes the most sense at companies because of the fact that they're trying to bring in external data. They want to play with this data, they want to work with it, and then when they're done with their discovery, then they evaluate whether or not to bring it into the on-premises or into their permanent cloud architecture. And in doing so, they're saying it's a lot of trouble, if you will, to really bring it in, get it through our DMZs, proxy servers, moving the data in, finding the storage, analyzing security. And it's almost easier to do this kind of discovery work in sandboxes that are cloud-based. Proof of concepts work the same way, but we're talking about new technologies where we can stand up a cluster and we want to try a new technology with that, whether it's on the analytics side, new code, analytic apps, custom coded stuff, but it's not really about discovering new data, and it's definitely not really about, with companies we see, about picking their Hadoop distribution. They've already made that decision. We're looking at discovery to take care of the data, proof of concepts to be evaluations. And then, of course, we have that separating of the environment into the SLA-driven, where we say these are operational applications, these are discovery. And then finally, what we have here is the number 3 driver, temporary elasticity. We know the cloud as being elastic, so the on-premises clusters are usually configured to be nominal. You can say that when you kind of configure your cluster, you're taking a look at what is our workloads, how much data do we come in, you do the normal sizing and capacity exercise. And then at that point, you round up for how much headroom you want. Well, in these cases, we're looking at how much to round up or how aggressive we want to be in setting our threshold. So that this is the bursting side. In that 10-100 model, we can also say we're going to run it pretty lean so that most of the time, looking at our workloads, we're going to be leveraging our cluster great, and then we're going to burst into the cloud 1% of the time, 5% of the time, so you can set how aggressive you want to be on your threshold. Now, the second model we see is kind of this surging model where volatility says that while we have additional either flows of data or user activity, we want to maintain the same performance. In doing so, we want to dynamically become more and more elastic to maintain a constant performance. And this is where we kind of mentioned that example of talking about electric grids, if you're familiar with them. During the days, the hot days of summer, the ACs and a lot of electricity consumption goes up, and electricity generation also drives and follows to meet that demand. So those are kind of 3 different architectural examples that we're seeing at companies that are getting implemented and worked out in the details. There's a lot of devil in the details, so we thought we'd kind of wrap up here with 2 things. One, deeper considerations. Number 1 is network connectivity. We do hear from our clients that in doing this, they kind of are getting a little bit of an eye-opener to the fact that the networks between their corporate data centers and clouds and the configuration, that there's a lot more work there than they had assumed. We draw lines on diagrams and think things connect, but configuration stability and latencies have kind of slowed down some of their implementations. So just be aware of that. Unified data access is another one because we look at the fact that when we're integrating with data warehouses or analytic databases and they want to work with the Hadoop ecosystem, moving workloads around is one of the things we need to focus on and not moving data around. We really don't want to extract all the data out of Hadoop into an analytic database. Too much data movement. We want to make sure that we have a single access point in database or virtualized in services, a semantic layer, and then we want to push those workloads down into the Hadoop clusters every time. And then finally, we really spend a lot of time going into, everybody thinks of the cloud as the infrastructure as a service model, but the platform as a service, the Hadoop on demand, is a really, really powerful use case to kind of fit into your overall architecture patterns. So our key takeaways we like to do is really to remind companies those business drivers have to be well understood. What is your context, if you will, and then take a look at the feasibility assessments that it takes to get there. Number 2, understanding how both infrastructure as a service and platform as a service can play together. It's not an either or. Cloud elasticity does come in various forms. And then the final takeaway that we have is number 3, which is just, we believe very much, and we kind of share this with our clients all the time, that strategic relationships that IT has plays a significant role in determining cloud and hybrid Hadoop architectures, because where you have those established resources, skills, vendor relationships, you want to leverage those, and you also will find that they have technology partnerships as well, which will speed the acceptance and the adoption of a hybrid architecture to go smoother, to be successful, but also to be realized quicker. And so we want to make sure we examine those relationships as well. So for me, that's kind of my little section here on what we see going on in the market from business client drivers to trends, as well as some of our key takeaways. So at this time, I'd like to turn it back over to Bob, and you can continue from here.
All right, thank you, John. I appreciate that. Good stuff. I'd like to step back a bit, and we talked a lot about cloud and some hybrid, and really, since we're talking about data lake for the cloud, let's talk about data lake and what we mean by that. Typically, when we engage with clients and customers, they've got some kind of new data type that they would like to analyze. They haven't been able to analyze before. It could be video streams. It could be streaming data coming from a bunch of devices. It could be clickstream data, something that they might not have analyzed before. And they will try to do a proof of concept, maybe get some value, and then say, you know, there's something here. What we'd like to do is do a little more of that, maybe with some additional kinds of data. So the scale starts to change, the scope starts to change. Eventually, someone gets an idea, maybe we should combine some of these kinds of data in our analysis that we've never been able to do before, because Hadoop makes that much more feasible. As we start to think about combining these data sets, we start to think about all kinds of other elements like governance and security and how these things all fit together and how they're all managed. That brings up what we're starting to call or starting to see as the data lake, the lake of data, where all the data flows in and lives to be analyzed or to be optimized or to be used to either drive down costs for the business or to increase revenue in some way, or whatever the organizational goals might be. Part of that data lake vision, if you will, that I alluded to was not just that all the data lives in one place, but that it has to be governed, it has to be managed, there needs to be controls around it, to the extent that you don't want this just sort of, you know, flowing out and showing up in the headlines of the New York Times or whatever it might be. Beyond the enterprise requirements of security and operations and the governance, there is the value on the upside, which is with a lake of data, with a lot of data in one place, you are now able to run multiple workloads, multiple applications that you really haven't been able to run before. Just as some examples, we see examples across all industries, many different examples. A lot of what makes this happen, what brings this to life, is not just that all the data is in one place, in the data lake, and it's governed, et cetera, but that with the introduction of Hadoop 2 in the fall of last year, we're really able to move beyond the old batch mentality of MapReduce into this kind of multi-workload environment where some folks are doing streaming analysis, some are doing live, there's interactive analysis that's happening, there are things that are running all the time, and of course there's, you know, batch and MapReduce is still there as well. But this unlocks the potential for different modes of access, whether it's through search, for example, or streaming data, and provides the ability to have applications that live on top of this data lake to do all kinds of amazing things. I won't read everything on the slide here, but we're seeing a lot of creativity now brought to bear because of this data lake concept. As a result, people are saying, you know what, this is becoming much more important to my organization, so I need to be thinking about things like backup and disaster recovery and ease of expansion with some kind of controlled costs. And a lot of what they're turning to, saying, well, how can the cloud help? So we've thought a lot about that as well. And one of the things that really makes a lot of sense to us and what we worked hard with Microsoft on was to make sure that whether you decide that you would like to deploy Hadoop and build a data lake on premises or in the cloud, that you'd want to use the same technology to do that. You wouldn't want to use one version of Hadoop and then do something else somewhere else. So Hortonworks Data Platform, HDP, we worked very hard between Hortonworks and Microsoft to create this environment which you can run this 100% interoperable data system, if you will, big data system, either on premises, could be on Windows, could be on Linux, or it could be through an appliance like the Microsoft Analytics Platform System. Or you could run it in the cloud with a managed service like Microsoft HD Insight on Azure, or you could run it as infrastructure as a service in the cloud, either on Windows or on Linux through Azure as well. So there's many different options where you can run both on premises as well as in the cloud. Now, great, that means that you have a good flexibility for how you deploy Hadoop, and you can think about deploying it in multiple places simultaneously. But the question then becomes, what interoperability do you get? Do you get the interoperability that you want? So in this case, having the two understand and know that each other exists means that you can say, well, I can partition, and some applications can run in the cloud, some applications can run on premises, and they can be the same applications. You don't have to recode them, which is very important. The other element to this is that if you are using the Microsoft System Center, then that is something that you're familiar with, and that is going to work well for you in managing and monitoring your Hadoop system, whether it is in Azure or whether it's on premises. One of the natural follow-ons is, now let us see how if these two can work together and know about each other. So I want to talk about how you do more, not just extending and having two different systems, one on premises and one in the cloud, but how they might work together for maximum benefit. So John talked about a number of scenarios. I want to reinforce those scenarios. We are seeing those. One is around development or proof of concept, where those can be done in the cloud. Another is that you can do bursting when you have peaks or spikes. And then we've got, backup and archive, what John called, I think he said, was it second class? I don't remember. All data is great data, right? And synchronizing these data sets are something that you're going to want to take a look at as you're thinking about how do we leverage these different scenarios. So let me go a little deeper on each of these. So let's talk about backup and archive, specifically to the cloud. You could think about the Azure Blob Storage really as a kind of an offsite backup, where you've got one or more of your on-premises clusters, and they are automatically sending the relevant set of tables or data sets off to Azure Blob Storage. There's a technology within HDP called Apache Falcon. Falcon can be set up to do this automated push, if you will, or sending of this data off to the cloud or to other data centers, if that's something that's important to you. What's important about this is that later you can then say some of that data that is in the cloud, either I can operate on that data directly, because it's not just in Azure Blob Storage, it could be in your Hadoop running on Azure. So you could operate it there, or if you needed to, pull it back into your on-premises installation and run analysis there. second scenario is doing your proof of concepts or your application development. Many times we see organizations wanting to bring in new data, but they don't necessarily know what the value of that data is yet. So they want to experiment with it a little bit and see, is this worth integrating into my production environment? Before you know that, before you commit to that, it'd be nice just to sort of play with it. So we see folks spinning up, for example, some cloud-based Hadoop clusters to be able to play with this data a little bit, do some experimentation. And it doesn't impact any of the things that are going on in the production systems. Very important, very powerful. And then when you need it, it's easy to transfer it in and then start all of the processing that you would do in it. It also means many times when you're doing development work, you can write applications that are, we'll say, very fat. They haven't been tuned yet. They haven't been created in such a way where performance and scalability is important, because you're just trying out some things on the application side. You're just doing these sort of proofs of concept. So the IT folks aren't worried about how much stress you're putting on the infrastructure because it's not being done in the production environment. What that does is allows you, when you have new applications that you want to bring them up into a cloud environment, for example, just specifically for development. And then don't worry too much about performance. Don't worry about impact on your other data or your other processing, your SLAs, et cetera. So we see it as a low-risk way and also kind of a controlled cost way of being able to experiment with data and try new things before you bring them in. Great for development and proofs of concept. And then the third is about bursting. John mentioned this as well. So obviously, as I pointed out before, you could run Hadoop in an environment where on-premises is one thing, and then off-premises or in the cloud is something different. Well, the sort of something different, meaning you need to have different procedures for management, different procedures for security, different procedures for data movement. That's going to be a headache. But if it's the same underlying technology platform like HDP or with HD Insight, you're able to move between them quite quickly. I want to make a distinction here between where the sort of state of the art is and what you might think of on the bursting scenario. Oftentimes what will happen is, as you know, in Hadoop, you move the processing to the data as opposed to move the data to the processing. And you do that because you've got to think about the fact that there's a lot of data. You might be moving a petabyte of data, and that could take a week, and you don't really want to spend that much time moving the data. So you'd rather just have the processor work on the data that's in place when you need it. And what that means is you can't just suddenly say, you know what, I have double the number of jobs that I have to run in the same amount of time that I did before. So let me spin up a cluster and then move all the data out there so I can do on-premises and cloud deployments. Instead, what we see is if in the cloud environment for the hybrid bursting environment, it's pretty common that in a lot of environments, one can say, you know, there's a lot of jobs that I want to just move off into the cloud while my on-premises job is going to complete much more quickly, or it's going to complete at all, right? It's an SLA job or it's a high priorities job. Or what we see often is there's ad hoc work that's going to happen along with production work. And we might say, you know, it's the end of the month processing, or it's the end of the quarter processing that needs to be done within the enterprise. So for the weekend that's coming up, we're going to focus all of our energies within the on-premises cluster on those production jobs, those end-of-the-month jobs, and we're going to have all the ad hoc work being done in the cloud. But is actually also, we equally see people saying, you know what, the ad hoc work tends to be long tail, and we're going to leave that all on the on-premises cluster, and the work that we're going to do for the end of the month or the end of the quarter can easily be done in the cloud with a little bit of data movement beforehand. So the point is that given your environment, you might find one or the other. And I think that these are actually quite powerful, these sort of bursting and partitioning scenarios that the combination of on-premises and cloud brings. With that, let's make it real. I'd love to turn it over to Matt and to show us a little demo. Matt?
Great. Thanks, Bob. So what we'll start off with, I just want to give a little bit of an overview of what we're going to show here. And the first is, and it's really about making the scenarios that Bob just talked about, making those real. And what we're going to do here is leverage a component called Falcon in order to handle the data movement. And what we'll see is we have a cluster that's running, our on-premises cluster. That's a HDP 2.1 cluster. It's running on top of CentOS, so it's a Linux-based cluster that's got Falcon configured to move data into Azure storage. And the important thing is that once we've landed the data into Azure storage, it enables those other scenarios that we talked about earlier in the presentation. If you want to have a duplicate cluster that you've got up and running in IaaS, you can certainly do that. And in that case, you've got a lot of control to match exactly what you have in your on-premises deployment. You could be running on the same version of the OS, the exact same patch level of the various Hadoop components. You could keep those in sync, you know, but you've got a cluster that you've got to manage at that point. Or you could leverage HD Insight, which is our PaaS offering for really creating a Hadoop cluster as a service. And in either one of those cases, you can point at the data that sits inside of Azure Blob Store and be able to pull that in. So now I will switch over to share my desktop. So we're sharing this, and what I'm going to start off with is I'm going to actually show Falcon here. And so this is the user interface for Falcon. I'll get into the XML here in just a little bit, but the notion around Falcon is really that I have clusters which contain feeds, which are various different pieces of data that I'm interested in. And then I'm going to have processes by which I schedule those feeds and say I'd like to keep this data, retain the data. And so what you can see here is we've got a very simple feed that we've set up, which is the clicks feed. And we're going to move that data between a cloud cluster and our on-premises cluster. And let's check out the configuration that I'm going to do here. So what I'm looking at here is the configuration for Falcon, and you'll see that I specify an on-premises cluster and my cloud cluster, and I'm specifying a couple of interesting things here. The first is the frequency by which I'm going to process this feed, so I'd like to do this on the hour, and then on each of the clusters I'm going to actually specify a retention policy for the data. So in my on-premises cluster I'm going to keep my data for 30 days, and then I'll delete it. In the cloud, what I will do is I'll keep the data around for 12 months. And so here we have a case where we're leveraging the cloud really for backup and for aging my data. And then there's two other bits of information that are important to configure here. The first is where does the data actually live? So this is in my on-premises cluster, what's the path in HDFS for the files, and here I've got clickstream data that's going to be partitioned into directories by year, month, day, and hour. And then when I move that up into Azure Blob Store, what you can see here is this is the blob storage path. And so this is going to point at something called demo container, and it's going to put it in this directory structure. And what we can see is once I publish this, this Falcon job, if I go and look at my on-prem cluster. So what I've done is I've SSH'd into that cluster, and I'm going to look in a certain directory. And so this is the directory from the job that most recently ran. Since these run every hour, I've pre-baked this demo, and you'll see I've uploaded this Hortonworks Microsoft demo.txt, and that's the file that's sitting inside of HDFS. Now, what will happen when the job runs, we'll pop back to the Falcon UI, and we can see there's a history of job runs that have occurred up here, and most recently the 2014-06-24, the 17th hour, that job actually ran. And so I have moved this data on the hour into Azure Blob Store. And the way to confirm this is we can pull up Cloud Explorer. This is a tool for looking at data that sits inside of Azure Blob Store. And you'll see that same file structure, 2014-06-24-17, is here inside of Blob Store, and that file is actually there. So now what we've done, we've used Falcon to move the data into blob storage. Now I'd like to actually leverage that data from a cluster that sits inside of the cloud. And so what I'll do here is move over to the Microsoft Azure portal. And so this is a single pane of glass for all of the services that you're running inside of Azure. And so if I've got websites or virtual machines or mobile services, I can see all of these here, and this is where I can create an HD Insight cluster. And so HD Insight is our Hadoop as a service offering. It's built on top of the Hortonworks data platform as the Hadoop distribution that we use inside of it. And really what we're trying to do with HD Insight is make Azure the best place to run Hadoop. And so we allow you to spin up a Hadoop cluster on demand. And so I can walk into the portal, go to HD Insight, and I can create a Hadoop cluster, or I can create an HBase cluster. There's three ways to create the cluster. The first is through this quick create, which is very quick. Give me 4 pieces of data. What's the name? How big of a cluster? The password information and which storage account would I like to associate it with, and we'll get it up and running. This is really designed to, get you started quickly, get you up and running to develop with a cluster. As you get more advanced, as you want to be able to do more advanced configuration options, we surface more knobs and dials in custom create. And so if I want to create a larger cluster than what I get in the drop-down here, I can certainly do that. So we'll pop over here. I'd like to create a Hadoop cluster. You'll see there's a set of versions for the cluster that I can go ahead and deploy. And you'll see these each correspond to a various version of HDP and then the subsequent Hadoop components that are contained within that. So we'll pick HDP 2.1. And then here's where I can specify the size of the cluster that I'd like to create. This is really, we will let you create as large of a cluster as you'd like. And so there are certain limits in the system that you have to give us a call and say, hey, I'd like to create a big cluster, but we can actually go and deploy clusters in the hundreds of nodes, and those take about 10 to 15 minutes to deploy to get that cluster up and running in any of the data centers that we have around the world. So once I have that cluster up and running, since it takes 10 to 15 minutes, I won't do interpretive dance between now and when the cluster is up and running, but I'll look at a cluster that's already running. And so this is MWinkle Summit Demo 3 that I will connect to. And I'm going to look at a command prompt inside of there. And the important thing to point out is when I created this cluster, I pointed it at that same storage account that I showed in Cloud Explorer, which is the same storage account that I've configured with Falcon to back up my data to. And so when I pop over into this cluster and I go to browse the file system, all I'm doing here is I'm saying I'd like to do the LS on my blob store file system. So by default, an HD Insight cluster will actually mount a Azure storage account as its default Hadoop file system, which means any file that gets written into blob store is available for me to process from Hadoop. And so what you'll see here is that same file, Hortonworks Microsoft demo.txt, is available here. And so what this would allow me to do is to take the same pig job or the same hive job that I've got running in my on-prem cluster, and I can run them here because it's just the file path is going to be the one thing that you change here, but you're going to point at this file and you can do all of the same jobs in both places. And so we'll flip back to the deck here and wrap up the demo. You know, we see a lot of folks coming to Azure for a number of the reasons that were discussed earlier. The notion around being able to kind of provision the resources when you need them and shut them down when you don't need them in a pretty easy way is something we see a number of customers being pretty interested in. We see a number of folks choosing to keep a Hadoop cluster primarily deployed on premises, either around control requirements or compliance requirements, or all of their other apps that are producing data are living in the on-prem data center. But even in those cases where people are, running their primary or production cluster on-prem, we think there are a number of interesting hybrid scenarios that allow you to blend and take advantage of some of the characteristics of the cloud, whether that's kind of an ever-decreasing price of storage or that elastic ability to provision a cluster. And we see those working together pretty nicely. And so right now I'm going to transition it back to Bob, who will wrap things up.
All right, thank you, Matt. Well, let me just leave you with a few things. I hope this was useful. We'll open it up for Q&A in just a minute, but I did want to have you consider next steps. You can get started very, very easily with the Hortonworks Sandbox. The Hortonworks Sandbox is a downloadable virtual machine that can run on your desktop or your laptop machine. That allows you to become familiar with the Hadoop environment. It also includes a number of tutorials. And if you'd like to use, for example, the most popular business intelligence tool in the world, Microsoft Excel, then we show you how to do that within the Sandbox as well. And there's a number of other tutorials included in the Sandbox. And we get a lot of very positive response from folks who use the Sandbox, so I encourage you to check that out. But also, you can also try Hadoop in the cloud and go to windowsazure.com/bigdata, and you'll be able to get started right away with Azure and with the cloud. With that, let me turn it over to Kim, who will lead us with some of the Q&A that's come in over the course of the last hour or so. Kim?
Great, thank you, Bob. That was really helpful, and thank you to the other two speakers as well. We do have lots of questions coming in. I'm just going to go through them one by one. So the first question is for John O'Brien. Please elaborate on the 1090 and alike in slide 9 that you mentioned, and if there are any guidance in establishing filters via semantics. That would be great.
John, you'll need to unmute.
Ah, there we go. Now I'm off mute. Great. Yes, so there are variations of the 1090, 10100, and 0100 architecture data models. Now, the 1090 model as an architecture really represents, kind of this tiered storage architecture, and you can set your tiers, 2-tier, 3 tiers, whatever you want. But when you're looking at something that jumps it a little bit that says that it's a 10100 model, what we're really saying is that we're doing a dual feed, that the second tier gets 100% of the data, while the first tier gets 10% of the relevant data within the architecture. So the benefit of this is saying that once data ages out, let's say tier 1 is the current month's data, or rolling 30 days is a popular one. That means on that 31st day, all we have to do is purge data from the tiered 1 part of the architecture without having to migrate it to the other one and add it and avoid all of that. Loading data is the most efficient way to move data around, to load it once. And you're absolutely right. I think the question there really is that there is a semantic layer that needs to be involved. When you put a semantic layer and says, I'm going to union both my 10 and my 100, you can either choose to set up a semantic layer for service level 2 kind of stuff to hit all of the tier 2 storage that has current plus history, or you can set up something as only tier 1, or you have to set the proper union, which can be updated to say, you know, current that is in tier 1 plus the history that is in tier 2, and you do a union with a filter statement in the semantic layer. So you're absolutely right about that, and there are several options on what makes the most sense. When we evaluate that, we do take a look at what is the user trying to do. Is the user's query a kind of SLA tier 1 query that needs to be into tier 1 storage as much as possible, or is it really a tier 2 query that can be met by the going against the 100% model? But we represent all of those in the semantic layer, so that's a great question.
Kim, any other questions that have come in that we should attack?
Yep, sorry, I was on mute. Another question that just came in for both Bob and you, John O'Brien. What is the difference between traditional production sandbox versus the data lake? John, why don't you go first, and Bob can be the secondary.
That sounds great. Yeah, I was trying to answer that in the chat window, and I guess I'm not as proficient at multitasking as I'd like to be. What's interesting there is that the concept of a production sandbox in some ways almost sounds a little bit like a oxymoron. So when we're looking at sandboxes, we're looking at environments where governance, agility, and those are the types of things that we want to embrace. So it's a much more freer, easier to use environment than a production environment, which is very much scoped out and set. When you relate sandboxes to agility, that's what's going to be our main business driver. When we look at the data lakes, what we see there is a central aggregation that says it's better to have all the data in one place for all the multiple uses that can run out of that, all the data integration without having to move around data. So it becomes much more of a centralization type of strategy where we're going to aggregate data to the benefit of all in the collaboration, so that basically everything starts at the data lake and works outwards. Sandboxes tend to be areas that, when you get into them, very predefined. The governance usually for us around sandboxes, you come in, you have a scope, you have so many days, you have so much resources, and when the time is up, we kind of say, okay, time to move out of the sandbox. We don't want people to keep piling into a sandbox and starting to create a production environment, but we wanted something that's very quick and low hurdle for people to get into. We manage that environment, and then we also move them appropriately to the next stage of their life cycle. Bob, what do you think?
No, well said. I really don't have much to add. Sandboxes you should think of as playgrounds. They're for trying and playing with things and seeing what works, and then once done, get rid of them.
Yes, and we set up those kinds of rules around the sandboxes. We can create an environment. We let people in. Sometimes we don't let them in unless they have a real project or a semi-real project with a follow-on life. We also share that there is no off-hour support on this environment. There aren't going to be backups on this environment. You have 30 days, 60 days, and then we also give you an extension. So we give a place to provision people to go play if we want to centralize that versus a discovery sandbox that can be more individual-based. But for the group or work group sandboxes, we do have some rules around them.
Great. Thank you, you guys. Next question is for Matt. Are the cloud solution run on dedicated hardware disks or shared with other users?
Yeah, that's a good question. And so there's no short answer to that one. It largely depends. You have a couple of different options, and it depends what exact end you're trying to get to. Some people are concerned about that from a noisy neighbor problem and want to avoid it. Some people are concerned about it from a security nosy neighbor problem and want to prevent it. And so you can, reach out to us and have that conversation. But the short answer is there are mechanisms that do enable that scenario of being able to kind of run on dedicated hardware. It just depends on, kind of how you configure it, if you're using cloud storage or if you're going to use the local disks that are attached to the machine. And we can walk through those options. Just follow up with me after the call.
Great. Another question that just came in for you, Matt. Do you need a 10/100 in order to choreograph a live event streaming analytics process during a burst mode time frame?
I think that's a question for John.
Yeah, so if you need some form of a 10/100, whether it is data synchronization that you bring in and you synchronize up to the cloud, the fact is that you have to have all of that data up in the cloud if you're going to move the application and burst it over to the cloud side. When you're going to manage your workloads like that, of course, the data has to be there for that application. If you have an application that requires all the data, moving it to on-premises or on cloud, it has to be running on the platform that has all the data that meets the requirements of that application. So I think the answer to that question is yes, something of a 10/100 model does need to exist if you want the application to port to the cloud in burst mode as well.
Great. All right, you guys, it's 11 o'clock, so it's at the end of the webinar. We do have a couple more questions left over. I'm going to try to get our speakers to address them and send them an email to you guys individually on your questions. So with that, I would like to thank our speakers today, Matt from Microsoft, Bob from Hortonworks, and John O'Brien from Radiant Advisors. And again, this webinar will be recorded. The deck, along with the recording, will be available on our website. You guys will get a nice personalized email from me directing you directly to it. And if you have any other additional questions, feel free to reach out to me, and I will try to get to you as soon as possible. So thanks, everyone, for attending, and I hope you have a wonderful day. Thank you.